Good evening, sir.
Yes, good evening. So let's just wait for 2-3 minutes. Hello. Yeah, I think
Hello, sir.
I'm audible, right?
Yeah.
So let's start. So I thought of solving few problems on delta potential and free particle, but I did not found a single question on that topic. So I thought of solving more problems on infinite potential well and harmonic oscillator for today. And from the next session, I'll go in some different topics like hydrogen atom or 3D potential. So today I thought of solving few more problems and few different problems on uh, harmonic oscillator and infinite potential well. So today what I thought you should try first, and if you face any problem then I'll solve the question. So I think that is okay. So let's just so what we need to solve the time independent Schrodinger equation, which is given by this equation. So we have to solve this Schrodinger equation for 1D potential, and there will be infinite solution, and the general solution can be expressed as psi Cn psi n, where mod Cn square sum over n should be 1, and the energy, average energy, is expressed as Cn square En. The first problem which we'll solve is GATE Physics 2014 question number 50. We need to use these properties to solve this question. So the question is a one-dimensional harmonic oscillator is in the superposition of number states n given by psi equal to this state. The average energy of the oscillator in the given state is, we need to find the average energy of the state. So I think you should try first and let me know the answer. So are you trying?
Yes, sir.
Yeah. Use this property and use the properties of harmonic oscillator. I think everyone should try the question. It's an easy problem.
So 13 by 2 h cut omega.
13 by 2 h cut omega. Not 2. Are you? The answer should be 13 by 4 h bar omega. Can you check again?
Yes, sir, 13 by 4 h cut omega.
Yeah. Others also got this answer. If not, then I'll solve. Anyway, I'll solve the question. So let me solve the question. The psi is given as,
Yes, sir. 13 by 4.
yeah. So let me. So as we have said that the general solution can be written in terms of the separable solutions. Here. So here C2 is half, C3 is root 3 by 2, and all other Cn is 0 for all others n. Except 2 and 3. So we know the average energy can be written Cn square En. And for harmonic oscillator, as we all know that En is n plus half h bar omega. So the average energy will be half square and 2 plus half for the second excited state, that is 2. There is, so in the value of n is 2, so 2 plus half h bar omega plus, here's C3 is root 3 by 2, so root 3 by 2 square into n is 3, so the energy is 3 plus half h bar omega 1 by 4 into 5 by 2 h bar omega plus 3 by 4 into 7 by 2 h bar omega. So this is 5 by 8 plus 21 by 8, that is 26 by h bar omega, which is 13 by 4 h bar omega. That is basically 3.25 h bar omega. So that is what asked in the question. This is not a multiple select question. It is, you need to write the numerical value here. That's 3.25 h bar omega. So it was not very difficult question. It was an easy question. So I think it is clear to everyone, right?
Yes, sir.
So if it is clear, then let's move to the next question, which is 2016's question number 55. The question is a particle of mass m and energy E moving in the positive x direction is incident on a step potential at x equal to 0 as indicated in the figure. The height of the potential is V0, where V0 is greater than E. At x equal to x0, where x0 is greater than 0, the probability of finding the electron is 1 by E times the probability of finding it at x equal to 0. If alpha is given as this, then the value of x0 is what? So you need to solve the Schrodinger equation and find the wave function first, and then you need to apply this condition that at x equal to x0, the probability of finding the electron is 1 by E times the probability of finding at x equal to 0, and then you can solve for this value of x0. So I think you should try this question first. Try and let me know the answer. The question is visible, right? Clearly?
Yes, sir.
Okay, then try it. First, solve the Schrodinger equation to find out the wave function. Applying the boundary condition that at x equal to infinite the wave function should be finite, and then find the probability at x equal to x0 and x equal to 0. The probability of finding a particle is just the modulus square of the wave function.
Sir, B 1 upon alpha.
I think B is not the correct answer. I think
Okay, squaring.
to find the probability you have to square the wave function.
1/2 alpha.
Yes, 1 by 2 alpha is the right answer. So you found 1 by 2 alpha, right? Option C is correct, so you need to find. If you have solved it correctly, then you should get option C. So has anyone solved? Rajiv Saklani, have you solved?
No, sir. No, sir.
Are you trying?
Yeah.
Okay. Okay, so Priyanka has also solved, and she has also got option C. So I think I should solve the question now. Let's solve. So the Schrodinger equation is d2 psi dx2 plus the potential is v0 psi. We need to solve it for x greater than 0, because at this point x equal to x0 we will apply the condition. So we will solve it for x greater than 0, v0 psi equal to e psi. So d2 psi dx2 minus 2m by h bar square v0 psi equal to minus 2m e by h bar square psi. If at any step you do not understand, then let me know. So d2 psi dx2 minus 2m by h bar square v0 minus e psi equal to 0. Since v0 is greater than e, that's why we have written this term in this way. So d2 psi dx2 minus alpha square psi equal to 0. As alpha is given in the question, v0 minus e by h bar square. So if we take psi in the form of e to the power mx, what we get is m square minus alpha square equal to 0, which implies m equal to plus minus alpha. So the solution to this differential equation would be a exponential alpha x plus b exponential minus alpha x. Here a and b are arbitrary constants. Now psi should be finite as x goes to infinity, but this term will diverge when x goes to infinity. So this term, so a must be 0. That so psi is of the form of e to the power minus alpha x, where b is an arbitrary constant. Now here the probability of finding the electron is 1 by e times the probability of at x equal to 0. So if we know the wave function, this is psi x, then the probability of finding the electron at x equal to 0 is this value, that is b square e to the power minus 2 alpha x naught, and the probability of finding the particle at x equal to 0 is psi at x equal to 0 modulo square. This is just b square. The condition is that at x equal to x0 the probability of finding the electron is 1 by e times the probability of finding it at x equal to 0. So this probability b square to the power minus 2 alpha x naught is equal to 1 by e times probability of finding at x equal to 0, that is b square. So e to the power minus 2 alpha x0 equal to e to the power minus 1. This b square will cancel out since b is not 0. This implies that 2 alpha x naught equal to 1. So x naught equal to 1 by 2 alpha. So option C is correct. So any question?
No, sir.
So it is clear, right?
Yeah.
Okay. So let's move to the next question. This is 2020 get physics question. This is a very easy question. So let's solve this question now. Let A and A dagger respectively denote the lowering and raising operators of a one-dimensional simple harmonic oscillator. Let n be the energy eigenstate of the simple harmonic oscillator. Given that n is also an eigenstate of A dagger, AA, the corresponding eigenvalue is, which one is the right option? So this is very simple question. You just need to use these two properties, that A dagger applying on n will give us root over n plus 1 state. This is the raising operator, so it will raise the state to the immediately upper states, and this is the lowering operator, which will give us root over of n and lower the state by 1. So if you use these two property, you can find out the correct answer for this question. So I think it should be done by everyone. So let's try everyone.
Sorry, is that option A?
Yes, it is option A. This is really simple problem, so this should be solved by everyone. Just use these two properties. Has anyone else solved it?
Yes, sir.
You have also found it option A?
Yes.
Cool. Okay.
So we can also use the commutation relation also and shift the operator and then do the.
Yeah, that is also possible. You can do it in that way also.
The A is right answer. N into N minus 1.
Yeah. So let's solve it. So EduUdr, A. This is an eigenstate of this n state, so we will get a value, and this one. So if we apply A on n, we will get what we will get is root n minus 1. Now this is just a constant value, so it will come out. So root n EduUdr. Now this A will apply on n minus 1, and using this property here, n is n minus 1, so it is root n minus 1, and the state will n minus 2. It will lowered by one state, and this is again another constant value, so n into n minus 1 EduUdr, and EduUdr applying on this state will use this property, and this will give us root n minus 1 n minus 1. So this is n minus 1 root n, and EduUdr again operating on this n minus 1 will give us root n and n. So this is n into n minus 1. So this is the eigenvalue of this operator EduUdr. So what we get is n into n minus 1. So option A is correct. You can also use the commutator relation of A EduUdr, which is 1, and shift the operators and find this answer. So this was really easy, and that type of question is asked in gate question. So if it is also done, then let's move to the next question. This is 2020's question, 22's question, and question number 45. So in this question, what is asked is that for a one-dimensional harmonic oscillator the creation operator acting on the nth state psi n, where n is 0, 1, 2, gives EduUdr psi n equal to root n plus 1 psi n plus 1. The matrix representation of the position operator x for the first 3 rows and columns is which one? So in this question you have to find the matrix representation of x, the position operator, for the first 3 rows and columns. So in this question also you need to use these two properties and you can find the matrix representation. Rituraj, you
So
asking any?
this should not contain the diagonal terms since the operator is inhalating and doing so diagonal terms should not be there. So we can eliminate option number 1A and D, and B and C will remain, and we can see if we apply dagger, then the value is n plus 1. So
Hmm.
diagonal the cross diagonal element should not also be
Hmm.
it should be same because one is operating on the higher state and one is on the lower state.
Hmm.
So cross diagonal terms should be same. Uh, so
Hmm.
the option C and B and C and or
Yeah, in that logic. So, but what option is correct? Option B or C? For that you need to calculate it.
sorry. Yes, we have to calculate.
Calculate it and let me know. Anyone solved it? You need to find the matrix representation of position operator like this. This matrix you have to find, and so on. So for there will be 9 terms. Hello? Hello? Am I audible?
Sir, C is right answer.
Wait a minute. Hello?
Hello, sir.
Yeah, I
C is
lost
right
the
answer.
connection from my laptop. So you are saying C is the right answer?
Yes, sir.
Yes, yes. C is right answer. So I was sharing screen. Let me share the screen again. So let me solve this. X is h bar by 2m omega a plus a dagger. We'll use these two properties, that a dagger psi n to the power of n plus 1 psi n plus 1 and a acting on psi n will give us root n psi n minus 1. We know that n starts from, sorry, 1 minute, there is a echo. Why is it not? So as we know, for harmonic oscillator, n starts from 0, 1, 2 and so on. So for the first 3 rows and columns, we have n equal to 0, 1 and 2. So the matrix representation will be like this. This is the first element, then this one, this is the first row. For the second row, these are the elements. Two. The final row is this. Let's first calculate the diagonal elements. The first element, which is this, can be found like this way: 0, and the value of x is a plus a dagger 0. Now we already know that if a operates on 0, this will give us 0. Since 0 is the ground state, we can't go below 0, so this is 0. And a dagger operating on 0 will give us the first excited state with some value, with only 1, the value is 1. So a dagger acting on 0 will give us this state. Now from the orthogonality property, we know that n m is delta nm. Since there is the ground state, so 0, and a dagger acting on 0 will give us the first excited state, so this is 0. So the total value is 0. Since a acting on 0 is already 0, and a dagger acting on 0 gives us 1, and together using the orthogonality property we get this is 0, and this should be applicable to all the diagonal elements. If we see that for the next diagonal element, we can use these properties and we can show that this is also 0, and similarly this one is again 0 using these two properties. So all the diagonal elements should be 0. Since in option A and option D all the diagonal elements are not 0, so we can rule out option A and option D. Only option B and C can be correct option. So the easy trick is that these two elements, these elements here and these elements, they are same, they are also same. So the trick is to find out this element, because these elements are not same for the two options. So if we find out only this element, then we can say which one is the correct option. So we will find out this one. One x 2, which is root over of h bar by 2m omega 1 a plus a dagger two. So there will be two terms. One is 1a 2, and this will be a acting on 2. This value will give us root 2 1 using this property. Using this property we get this one. So sorry, this is the constant term 1 1, and from orthogonality property this is 1, so this will give us root 2, and the second term is 1 a dagger 2. So now a dagger applying on 2 will give us root 3 and the state 3. So this is root 3 1 2, sorry 3. So using orthogonality property we can say this is 0, so this is totally 0, and the total value of this is root 2 into root over of h bar by 2m omega. Root over of h bar by 2m omega is already outside there, and what we get is root 2. The constant value is root 2. So option C is correct. And so without calculating every elements in the matrix, we can just calculating one element, we can say that this option C is correct by ruling out other options. So I think this is also clear. Or anyone have any question?
No, sir.
Okay, so for today I have choose these four question on harmonic oscillator and potential well. From the next day I'll try to cover 3D potential well and hydrogen atom and solve few questions on that topic. If you have any suggestion, then you can suggest if do I need to cover more topics or should I solve more questions, like should I cover more theory part or should I solve more problems?
Sir, you should solve more problem.
Okay, I'll add more problems for every session then. So this is the end of this harmonic oscillator and 1D potential well. If you have any problems in regarding gate questions on these topics, you can send me on my mail ID. I'll write my mail ID here. So this is my email ID. If you have any problems from gate questions on these topics, like this uh, harmonic oscillator and 1D potential well and any step potential well, then you can send me on this mail ID and I'll try to solve. So you note down the email ID. For the last 3 sessions I have solved 4 questions per session. So how many questions will be adequate for each session? 5, 6 maybe. Look, you are always welcome to give suggestion to me. So anyone else has any suggestion, you can give. Yes, Rituras, are you trying to say something?
So some problems come from the scattering cross-section part, which is very difficult to solve, I think, from my perspective. So some questions of that should be beneficial.
Sorry, can you repeat some problems from?
So some question of scattering
Yes.
cross-sections come in the course.
Yeah, sure. But that will come later. From I'll start it from harmonic oscillator first, and then hydrogen atom, then perturbation theory, and that way the scattering problems will also come.
Okay,
But I
thank you.
don't want to skip these problems and directly go to scattering first. So I want to do it like this way.
Okay, sir. Thank you.
Okay, so if anyone else doesn't have any questions, we can end the session today. And from next session, I will try to add few more questions. We can definitely solve one more question in 1 hour, I think. So if you have any problems, you can definitely feel free to send me on my email ID. And if there is, yeah, thank you. So if there is no other questions, we can end the session here.
Thank you, sir.
Thank you, sir.
Thank you.
And sir, hello, sir.
Yes, yes.
Sir, in next class, so we are studying about hydrogen atom, right?
Yeah, I think this 3D potential will
And hydrogen atom.
yeah, and hydrogen atom. It's
Sir,
very
so
common.
when you are taking hydrogen atom, could you explain some theoretical part too?
Yeah, definitely. I'll do that.
Like
First,
we are aware about the mathematics. Like, could you speak some physics about that? Like, I'm not completely aware about that.
yeah, sure.
It
I'll
would be
try
very
to.
helpful, sir.
Definitely, I'll keep that in mind.
Okay, sir. Thank you, sir.
Thank you.